All right, welcome to part 3 of solving LeetCode easy questions. So I'm in the LeetCode problem section, and let's go ahead and select algorithms, difficulty easy, acceptance rate, and sort it down and make sure there's no gap. Okay, it seems there isn't. Okay, and then I think it's better to just open like 10 new tabs and then just focus on that basically. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait, it was 9, right? How many numbers are, okay, so this is the 10th. Okay, gotcha. All right, cool. So we'll just start from here and then, start the timer basically. All right, let's start the timer and here we go. All right, let's go. So it says, given a positive integer n, return the smallest positive integer that is multiple of both 2 and n. Okay. So I think this is a pretty simple math problem, right? So basically 2 is a prime number, which means that if you choose like any n, you can essentially return 2 times n to be divisible by both 2 and n. So for example, like if n is, say, let's say 11, right? The smallest number divisible by both would be 2 times 11 because 2 is a prime number and then the other number doesn't matter, right? Unless it's the n itself is 2. So if n is 2, we return 2. So that's the only edge case that I can see. So if it's 1, then 2 times 1 is still 2. So that's good. So basically what I want to do is if n is equal to 2, return 2. Otherwise, we just do that, right? So let's just try and see how it goes. Oops. Oh, yeah, right. I didn't. Funny. Also, I didn't account for the even numbers then. Yeah. Okay. I'm so dumb. Right, so basically this case becomes like if n is divisible by 2, then return n divided by 2, right? So that's gonna be, wait, is that correct? N is, no, not divisible by 2. So we just return n, right? So if n is divisible by 2, just return n. Yeah, okay, that's good. I think this is the other case that I was talking about. All right, I think this is all good. Yeah, 2 is a prime number, but unless the other number is divisible by that number, it's also the multiplication would be the smallest, right? I mean, the number itself would be the smallest. So there's also like a shorthand in Python where if you want to do it, you can do it. But sometimes people prefer this. Sometimes people prefer the one-line solution where, so I can essentially turn this code into like one line saying return 2 times n if n divisible by 2 is 0. So this is basically like if this is true, return that, or we just do else, which is n. Oh wait, sorry, I think I messed up, right? Return n, otherwise n times 2. Yeah, okay, so yeah, this is good. So I just basically copy this here, and then the return in here, and then the else branch would be that. So basically, if you want to read this, reads as like if n is divisible by 2, return this, otherwise return that. So that's how it reads. So yeah, that's the first problem. And the time complexity of this would be just O of 1 because there's just one operation, right? And then the space complexity is also O of 1 because we didn't store any numbers. Okay, let's go next. Minimum number of moves to seat everyone. Okay, this seems like a complicated problem. I wonder if I should just skip it. Okay, let's just do it for and if it's really, really complicated, then I might save it at the end, but let's just go ahead and read it. There are n seats available, n seats available seat, and then n students are standing in the room. Okay. You're given an array of seats length of n, where seats of I is the position of the ith seat. Okay, you're given the students of length n, where students j is the position of j's student. Okay, I guess. Move from the following, move to any number of times. Okay, increase to decrease the position of I student by 1, i.e. I student would go to x plus 1 or x minus 1. Okay, so basically just move the student position to like increase or decrease it. Return the minimum number of moves required to move each student to a seat such that there are no two students at the same place, the same seat. Okay. I think on these kinds of problems, it's easier to just look at the it's sometimes easier to just look at the example. So what I'm understanding is basically, so we have number 3 seat and student, it's like at location 3, right? I think so, yeah. And then student is at location 2. So we want this to move here, I think. Or is it otherwise? Oh, no. Yeah, okay. So we want this student to move here. No, that's not the case. We want this student to move to any seat, right? It can be anywhere. So basically, the first student would move to position number 1, like this here, because that's the closest one, right? And the 7 would go to there, and then the 4 would go to 3. So basically, like each student just goes to the closest location, and that's the optimal solution, basically. Okay, and then let's see how it goes here. Student 1 goes to, I mean, it's in the same location, so we don't move, right? And 3 will go to 4, I would assume, right? So 3 goes to 4, yeah, that's correct. And then 4 will go to 5, okay. Not 4. 2 will go to 5, and then 6 will go to 9. Okay, that's 3 more. That's the minimum. Okay, cool. Note that is okay. So 4. So these would be like, okay, 1 goes to 2, 3 goes to 2. Oh wait, sorry, no, that's not the case. 1 goes to 2, 2 stays the same. 3 goes to 6, 6 stays the same. Okay, I think that's how it goes. Let me see if that's the case. Position 1, it's moved from position 1 to 2. Yeah, that's correct. And then 3 goes to 6. Yeah, that's correct. Okay, cool. This problem is a bit tricky. Like, I don't see this problem as like easy problem at all, to be honest. Like, sometimes this happens with LeetCode, right? Whenever like there's an easy problem, but it's not actually easy. It's technically like a medium-ish problem. But the thing about the sorting mechanism that I did is because like these three test cases were so good that whenever people run it, get accepted basically. So if you could pass these 3, you can just get accepted basically. So that's how it is. I think this problem may be like a greedy problem where, you just basically choose the closest location and that's the answer. So I think that might be the case. But in terms of like greedy problems, you have to prove that it is the closest, right? So, but I don't think we should be doing the proof. I think in this case, we just need to know, okay, maybe that's the solution and see if that works. I think that's going to be a good tactic. Okay. What else is there? There can be multiple close locations though. Like, for example, like if there were, yeah, for example, like here, right? So you have 3 and 1. Which one do you choose though? I think you have to sort it and then do some greedy algorithm or something. You have to sort it based on the student's location and then just choose from the beginning and then go from there. I think that's a good problem, a good approach to have. Let's just see if that's the case. Okay, so we have student.sort, so that's sorted, and then just go. Oh wait, is it just? Wait a minute. Do we just sort it and then see the respective differences? Is that it? Like sort both of them? Nah, that can't be answer, right? Maybe it is. Because so let's just try, right? So we have 1, 2, 3, 6, and then 2, 2, 6, 6. Okay, so that's correct. And then 1, 4, 5, 6. So I'm just trying to do the second example, and then on the so basically you just take the difference in here, 2, 2, 3. 2, 2, 3 would be 7. Okay, that's correct. And then on the first one, 3, 1, 5, 2. Oh wait, not 3, 1, 5, 1, 3, 5. That's order 1 would be 1, 4, 7. Okay. So we have 1, 1, 2, which is correct. Okay. You know what? Let's just try that and see what happens. I'm really curious if that's the answer. So basically just for sort both of them and then do the difference and add the differences, right? So students, but I'm really curious if this is the right answer. I don't think this is the right answer, to be honest, but I might fail because like, what happens if there were a case like 1, 1, 1, 1, 1, 2? I guess it is still the answer. I'm thinking like this. Okay, so basically I'm moving everything up here to here, but there's already 2, 2 that does 0. So essentially, so what's the answer in here? 1, 2, 3, 4, 5, 6. 6 plus 2, that's 8. So that's the 8 is going to be the answer on our algorithm. But in reality, this is essentially the same as this 1, 1, 1, 1, 2, 2. I guess it's still the 8. Okay. I guess it works out that way. Let's just see. Oh, wait, this is difference. We have to take the absolute value. Okay, I guess that is correct. Let me see. Okay, that's correct. Yeah, I think that's just a greedy problem, right? So you just basically sort everything, and then basically just goes to the corresponding position. And I think we have to prove, I mean, it is the solution, it is correct, but we just have to prove that this greedy solution is the optimal solution, basically. That's going to be challenging, but I don't think I'm going to do that here. Just intuitively, it makes sense. Okay, and the time complexity and space complexity would be, so time complexity would be O of n log n because we are doing sorting, right? But space complexity, so I mean, you can argue it's 1 or you can argue it's on because it depends on the internal implementation of the sorting, right? So some languages do like on sorting, some languages do o1 sorting. I mean, if it's a quick sort with like indices correctly implemented, then it's o1 sort. But if it's not a quick sort, then they might use some sort of like merge sort or whatever like that, and it's o of n, right? So it just depends on the implementation. And I think Python, it's maybe like O of n, if I'm not mistaken. All right, so let's move on. Okay, so this was definitely like, I don't think it was an easy problem at all. I don't think so, at least. I mean, it may be easy, but it's like the hard end of easy, at least. So yeah, that's the case, I think. Okay, so let's go over here. There are n employees in the company, a number from 0 to n minus 1. Okay, each employee I has worked for I hours. Okay, and then the company requires each employee to work at least target hours. Okay, you are given 0 index array of non-negative integers hours and length and also the target. Okay, that makes sense. And then return the integer denoting the number of employees who worked at least target hours. Okay, I think that's not too terrible. Oh, okay. So target is just a number. I thought it was an array also. Okay, that's good at least. All right. So basically, this problem is like it's super easy if you are just gonna do loop, right? of n solution. So let's just do that first and solve it that way, which is not the optimal solution, of course. So what I'm gonna do is for I h in hours. So we have to enumerate it, right? So that way we can get the index and the hour at the same time. So now what we do is like, okay, if the hour is less than or equal to target, or not less than or equal to, is it? I guess that's correct. Yeah, less than or equal to target. Wait, no. Sorry, I think it's this one actually. If it's greater than that, that means, so wait, sorry. Oh yeah, the hours are not sorted, right? So it has worked for hours in the company. Each employee's hours, each requires employee at least 10 hours, 0 based on this already. Okay. This is not sorted, right? So there's no such thing as sorted here. Okay, yeah. All right. I think we have to do iteration then. I thought it was sorted for some reason, but so let's just do like result, I guess. Result is 0. So yeah, sorry, I was mistaken. So basically, this is just like such a super easy problem where if h is less than, oh wait, not less than target, greater than or equal than target, you just add the result, right? And then return the result. I think that's just it. It's just the number of employees who met the target, right? Okay, yeah, that's good. So yeah, there's no optimal solution than this because it's not sorted. The array can be arbitrary. You have to go through each and one of them to know if it's completed the hours, right? So time complexity is O of n, space complexity is O 1 because we didn't do some sort of fancy like variable declaration. But this question might be might change if we were calling this function many times, right? So that's going to be, if that's the case, then we might change this implementation where we do some sort of fancy binary search to optimize the search time. First sorted once first, and then you just do binary search, right? So that can be like another follow-up, I guess, on this question. But for this question alone, it's not like that. So we just do this solution. All right, so let's go to the fourth problem. Kids with the greatest number of candies. Okay. There are n kids with candies. You are given an integer array candies where candies I represents the number of candies that the ith kid has, and an integer extra candies. Okay. Denoting the number of extra candies that you have. That you have? What? Okay, I guess I as a parent or something I have extra candies, okay? Return a Boolean array result of a Boolean array result of n where result I is true if after giving the ith kid all the extra candies, they will have the greatest number of candies among all the kids, or false otherwise. Note that multiple kids can have the greatest number of candies. Okay, so basically, if I give my candy to this person, to this kid, then this kid will have the greatest number of candies, right? So that's true because the maximum is 5. And then this will have 6, which is also greater than 5. That's true. It's true. But these two person, oh yeah, I guess this one can't, but this one does exceed the maximum. So that's why it's true. So basically there's only one false where this kid wouldn't reach the maximum, I guess. So first we have to find the max candy, right? So which means we can just do max of the candies. So now we have the max candy. That's just a simple max function, right? And then what we do is go through the candies one at a time, seeing candies, and then see like, I guess we can just create like a response array where we have false, I guess. Yeah, let's just do false times length of candy. So every entry is initially false, and if c plus max candy is greater or equal than the, oh no, not max candy, sorry, it's the extra candies, then we have to compare with the max candy. And if this is the case, then we just do, oh yeah, I guess we just need the index as well so that we can, modify the response array. So you have to do enumerate. Oops. Okay, let's just do this. And then I is equal to true. And then return response. Okay, I think that's good. Let's just try. All right, good. I think this is a good solution. And again, there is no optimal solution than this because we have to go through each candy, right? So to get the maximum, to know if it's the max or not, something like that. Okay, so time complexity is O of n, and the space complexity is also O of n because we created the result array, right? So that's going to be the O of n space complexity, and the time complexity is just, we're just iterating through to get the max and also iterating again to modify the array. Okay, let's move on to the next one. All right, what does this say? Widest vertical area between 2 points containing no points. What? Okay. Given n points on a 2D plane, okay, where points, okay, so every point has a coordinate x and y, return the widest vertical area between 2 points such that no points are inside the area. Vertical area and the area is fixed width extending infinitely along y-axis, infinite height. Widest vertical area is the one with the maximum width. Okay, note that points on the edge of the vertical area are not considered as included in the area. Okay. Widest vertical area between 2 points containing no points. Okay. So what's this saying? Both red and blue are the same, are going to be optimal. Okay. I guess there's just some sort of bunch of points. I guess this picture could have been better. They could have gotten a good example. But essentially, you're just looking at the largest difference on the x coordinate, right? So you don't care about the y coordinate at all. So y, as far as I'm concerned, like a y can be all zeros, and then it's still the same problem, right? So you're just comparing the maximum, and then you're just trying to return the maximum difference between 2 points. So that's it. All right. So in here, right? So I guess, wait, what? I guess that's not the case. 3, 9. Oh, yeah, sorry. You have to sort it first, though. Yeah. Okay. I thought this was like 6, and then why is not 6 the answer? Okay. So yeah, the answer is like obviously a 5 and 8 difference of that. So basically you sort it first, right? And then after you sort it, you do just linear search on like the largest gap. So that's going to be the answer. So I guess the trick to this is like, how do you sort it by the x coordinate, right? So that we have to sort it by the x coordinate. We don't care about y coordinate at all. So what you do is like points sort. In here, I think, what is it called? I think it's key and then lambda x of 0. I think that's it. So essentially what this means is that, okay, I want to do custom sorting, right? Okay, well, how do you want to customize it? It's a key equals is going to be my customization. And this part might be really, really confusing for you guys, but essentially what this means is that I'm creating like a custom sorting function, right? So let's just say my function, and then it gives me a number, and then I'm just going to compare it with the, so this gives me like an array, right? So each element of points is an array, like this thing. And now I want to, this gives me like a point, and then I want to compare it with the first point, like which is the x coordinate. So that's why instead of writing this thing, so instead of writing like my func like this, so this is like too much space, right? What you do is like create like a lambda function. Lambda function means it's like an inline function, right? So it's like, except, it's instead of creating like a def and then function return blah blah blah, you just do this. So that's like a shorthand for creating a one line function basically. All right, so after you do that, so it just goes through one point at a time, and then I think, I guess you can do 0. Yeah, you can start with 0. Max width is equal to 0, and then range length of points minus 1, because we're going to compare to the next one, right? So points of I of 0 minus points of I plus 1, I'm comparing to the next one. And then maximum of that versus max width. So we're comparing these two, and then we just assign it to max width, and then return max width. Let's see what happens. Oh, it's wrong. Okay, wait. Oh yeah, right. So you have to do, I guess you can do 1 minus 0 because it's sorted. Wait, sorry. This is still 0 plus 1. That because this was comparing it as a negative, right? So that's why. I was going to do like an absolute value, but you don't need to do that, because you can just do this. This is always going to be positive because it's sorted, right? So yeah, that's it. All right, so Okay, this is interesting. Why are there so many people that are in this section? It's so confusing. Is it doing just like ON score solution that make? I have no idea what these solutions are, to be honest. Because I don't think there is a linear solution to this. You have to, yeah, you have to compare. There is ON square solution, of course. You can compare every one of them. Oh yeah, wait, no, you can't do that because there's a points in between. So you have to sort it. Yeah, I have no idea what those in the middle are. It's really try sorting the points. Think of the value, points of relevance. Yeah, sorts. Yeah, I don't know. I mean, I don't know. I'm really surprised about that pointing graph. I think those might be when the server was running like really low capacity. I mean, a high capacity or something. I have no idea. But still, I think this is the optimal solution. Correct me if I'm wrong, though. Time complexity is of n log, and space complexity is, like I said, this can be O of n or O of 1, depending on the sorting algorithm, but I'll just say it's O of 1 because I didn't create any new. Theoretically, it's O of 1 because we can do quick sorting to do O of 1. Yeah, so let's just go with that. All right, that's it. Count pairs whose sum is less than target. Okay, what does that mean? Given zero indexed array, integer array nums of length n, then the integer target, return the number of pairs I and j, where I is that, nums I, nums j is that. Okay. I guess you just do two nested loop and then count that, right? I don't think there is another way. Yeah, I don't think so. Okay. Yeah, I don't think so because you cannot sort or anything like that because it's dependent on the index. So how are you going to do that, right? So I'll just do in range length. So essentially just do two nested loops, and then this condition will be automatically satisfied, right? Because what I'm going to do is I'm going to start from I plus 1 and then until length nums. So that automatically satisfies the condition. And then what I'm going to do is count to 0. And then if the, what is it called? Nums of I plus, let's just copy this thing. So if this condition is true, then we increase the count. Otherwise, we just don't, right? Just increase, and then let's go move on essentially, and then return the count. Yeah, I don't think there is any optimal solution than this because we can't mess up with the array at all. All right, cool. So the time complexity is O of n squared, and then the space complexity is just O of 1 because we didn't use any extra space. So, okay, that's cool. All right, let's go to the next one. Goal parser interpretation. Okay, you own a goal parser. I don't know what that is. Okay, interpret a string command. The command consists of alphabet G, parentheses, and or parentheses AL, close parentheses, and some order. Okay. The goal parser will interpret G as the string G, and this one as the O, and this one as L. Okay. And the interpreted string are all the concatenated in the original order. Okay. Given the command goal parser, interpret the command. Okay. This is so weird. I guess basically what it's meaning is like whenever you see this, turn it into an O. Whenever you see this, turn it into L. So it's like goal, right? So there's like 4 O's in the middle. And then, okay, yeah, I mean, it's pretty straightforward. Like it's a really simple string manipulation problem. So the trick to these kinds of string manipulation problem is that you have to use some sort of like a string builder, right? So in Java, it's called the string builder. But in Python, what you do is like basically create an array and then join them together at the end because string is immutable type, so which means whenever you assign it, you have to overwrite it into the memory and then create a new one, right? So but with array, you can just append to it, and then the memory location is the same, but it just keeps on expanding, right? So that's like really, really efficient in terms of computation. So what I'm gonna do is, oh, this is actually like a not array, right? Oh, okay. So this is a string. Okay, I guess it is kind of tricky. Huh. Let me see. Let me think. So you have to analyze the next character as well. To know, because I thought it was an array. If it was an array, it was going to be really easy, right? But I guess I can do something like I in range of length of command -1, because I am going to analyze the final string, right? Oh wait, should I do that? I don't think I should, because the last character can't be G. So what I'm going to do is this: if command of I is equal to G, then that's the straightforward case, right? So s dot append G. So just append the G. But L if so L if is gonna be like, so it's obviously gonna be parentheses, right? So you have to just analyze the next character. So L if I command I plus 1 is equal to close parentheses, then s dot append, that's O, right? Oh, it's small o, okay. And then if it's everything else, then just do append AL. I think that's it. And then what you do is like you do join. So join with like no characters in between, and then just S. I think this should work. Oh yeah, index out of range. What? Oh wait. Oh yeah, right. So if it's that, then I cannot just do that. Okay, cool. I was thinking of too simple. So this should not be a for loop. This should be a while loop then. Okay, so okay, I'll try to explain what that means. Length of command. All right. So in this case, the index should just increase by 1, right? But in this case, the index should increase by 2 because there are 2 characters in the parentheses, right? In this case, the index should increase by 4 because this thing is 4 characters, right? So that's how it should be. So let's just try and see if this works. Okay, yeah, that worked. Because for the for loop, the I is just going to increase 1 by 1 all the time, right? So we don't want that, because if we go here and then here, then that's a problem, right? We don't have a case for this, and then we're just going to be appending L all the time, so which is not what we want. Okay, so I hope that makes sense. Okay, so let's just try and submit this, and then write the time complexity. Time complexity is, oh wow, it's super fast. Okay, 99.65. Okay, that's good. Time complexity is of n, like the number of letters in the command, hopefully. And then the space complexity is also of n, because we are creating this response and then just joining it, right? So that's why it's of n. Cool. All right. Range sum BST. Okay. This might be tricky. This is one of those problems where it's not really a easy problem, but it is. No, sorry. It is a medium problem, but it's in the easy category. You know what? Let's just do this at the end, then skip to this problem first. So how many numbers are smaller than the current number? Okay, what does that mean? Given the array nums, for each nums of I, find out how many numbers in the array are smaller than it. Okay, that is for each number of I, count the number of sides such that yeah, okay. Okay, 4, 0, 1, 1, 3. I see. This might be really, really tricky though. Because there is a brute force solution, right? So the brute force solution is basically like do a nested loop and then count how many small there are. Okay, let's just do that first and then we'll try to optimize it and see what happens, right? So range, length of nums for j in range, length of nums. Or wait, so I think you can even what if you okay, let's just do this first and then try to optimize. So I was thinking about the optimal solution. Okay. If I equals j, I guess it doesn't matter. You can do something like continue, but it doesn't really matter because the condition is not going to be the same anyways. Nums of I. Okay, so response is the array, and then we do count is 0, so we're just gonna count one by one, right? So if nums of I guess it's j is less than nums of I, right? So that's the condition. Count one, and then not return, sorry. Response dot append count return response. Okay, result or whatever. Okay, yeah, that works. So this is the O(n) squared solution, right? So this one is like time complexity is of n squared, and the space complexity is of 1, right? So that works. Wait, not a 1, sorry, it's n, because we have a result that is array, right? So, okay, so this is the brute force solution, and it definitely works. Let's just try if it works. Okay, yeah, it does work, but as you can see, there's like a bump in here, right? So I'm sure there is a optimal solution. Okay, what's the optimal solution, right? What I'm thinking is you can definitely sort it and then count it, right? I think that's like the best approach. But what I'm thinking is like in this case, right? So 777, like you can sort it definitely, but everything is the same. So you have to do some fancy stuff to count how many of them are like equal on this space, right? And then return this. So that is really, really tricky. That is tricky. But you can just do that with binary search too. But I guess yeah. So basically, what you do is you sort it. Okay, you sort it, and then you do binary search to find the next smallest number, I guess. Then the position, I guess. What's the position on there? So let's just try to do that. Okay. So what you do is nums dot sort first. Okay, that's sorted. And then you go to you just start from the oh wait. Then you lost the index. Okay, I don't think you can do straight up sorting because you lost the index. You have to keep the index. That's a shame. Because you have to return array that is associated with the index, right? So okay, I'm pretty sure if I'm gonna be doing the optimal solution, that's like gonna be like a medium-ish problem, but I'll just do it anyways. How should I approach this? All right, so you have to keep track of the index for sure. And then once you do that, you just do you sort by the index again at the last? I guess that's the case. All right. So you cannot just do this. So you have to do like nums index, like a list, right? And then for I and in nums, you have to enumerate it. Oops. Right, and then nums index dot append. So you have to append the number and the index like this as a tuple. I mean, you don't have to have a tuple, but I mean, if you're using Python, I would suggest tuple because those are like immutable, right? You're not going to add like a list that is trying to expand or anything like that. But tuple is a really good data structure for these stuff. Okay, and then you do your sort. Okay. Oh yeah, I guess I forgot to mention that whenever you do something like nums index dot sort, it automatically captures the first element if it's a list or a tuple. I should have mentioned that in the previous problem actually. So which one was it? It was a custom sorting problem, right? Was it this one? This one? Oh, not that. Not this one. Oh, here, right. So you didn't really have to do this. So let's just delete this and then see if this works. Because I'm pretty sure it does. I totally forgot about that. Okay, yeah, still it works. So it just automatically defaults to this, like the first item. So you can do this, you can do that, or it doesn't really matter. All right, never mind. Let's go back to here. Okay, you sorted it. And then once you sorted it, what you do is like, okay, go through one by one. And then, also you have to create another array, right? So I guess smaller numbers and then like that, and then you do, I guess you need the index too. So in nums index, so you do a number and index together. And then what I'm thinking is like smaller numbers dot append. So count and then index like that. So this count is like, okay, how many numbers are less than this current number, right? So it would just give me that. So I'm creating like a function for that. And then what you do is like you return this, but you only you sort it by the index and then return the numbers basically. So it's a really, really tedious process. Is what I'm trying to say. How are we doing time? Okay, I think I can do it. Let's just do it. Let's just man up, I guess. Okay, and then the count is like smaller count. I guess let's just do get smaller count of nums, and then the current number is n, right? So count how many numbers are smaller than n. So that's the method that I'm trying to complete. Get smaller count nums n. All right. I guess I should. Okay, there are a couple of ways of doing this. I think I should be turning this thing like yeah. So it is the sorted one. So I should be returning passing in the sorted numbers for sure because I want to do binary search, right? All right, cool. Now there is like implementing binary search on itself is a challenging problem too. Okay. So there's a trick to it. Okay, let's just do like, so binary search is like you have to have left and right pointers, right? So the left is going to be 0, then the right is going to be the last one. And then while r is greater than l, right? Okay, all right, let me see. Is this true? I think we'll get back to this. This it might be this depending on the situations, because in binary search there's so many situations there are, right? So the easiest one is like if the number exists or not. But on these kinds of things, you have to find the index that is the leftmost, right? So you can't just say, okay, this is the number that is in the array, but you have to return like the leftmost index. I guess this should be like not left smaller count. It's like the left index or something like that, but never mind. So now what we do is like L plus R divided by 2, that's the middle, right? And then if nums of mid of 0, so that's the number, if that is equal to n, right? So this means that we have to search the left side. So, and also this is excluding, let me see. I think we should be excluding, right? So, which means L stays the same. L is still on the left, but we have to update the R. R is mid minus 1. And then else, the left is equal to R, because I think, wait, let me see. Oh yeah, if it's not equal, right? So, no. I think there should be a case where greater than R, or maybe less than, like this. Let me see. Okay, so if the mid number is that means, I'm trying to think. If the middle number is less than our target, then we have to search the right side, which is, okay. I think this should have been this thing then. If it's larger, so if it's larger than the target, then we keep searching the left. So we pick the middle, the target is there. It is larger than that. Okay. Yeah, I think this might be it. And then we just return L basically. So 0, yeah, this might be it. But this is also like really, I still haven't fully figured this out yet, but I mean, it requires a thought process for sure. Let me see if this is correct though. Okay, so we have this thing, and then what we do is like smaller numbers dot sort. I guess I can do I and then count so that the sorting makes it easier, because it's gonna be sorting for the 0th one, right? After it's sorting, then the result is gonna be like, I guess I can just return it. You know what, I'll just do it this way, and then I will show you the shorthand. For I count in smaller numbers, result.append. We're only interested in the count, so return result like that. Okay, it is wrong. I mean, it is pretty close though. Okay, I guess it's not that close, but it is kind of close. So I'm pretty sure it's wrong in here. So there are like one tiny mistake, but is this correct though? Let me think. Maybe it's greater than or equal, or is it an infinite loop now? Okay, maybe it might be like infinite loop now. Okay, so these are like -1 +1s are really important. Okay, so time limit exceeding here. Let's just do this. So how are we doing on time? So we have 10 minutes left. I think I can do it. So yeah, L1. Is it like, oh wait, why am I doing R though? It's supposed to be mid. That's so stupid. No, it should not be R for sure. But I think there's also like a +1 -1 difference. Okay, so like that. it's really bad to just guess this. I think it's really important to understand it. But right now I'm just guessing because I have a time constraint to guess. Okay, so we are doing output is 0. Why is it 0 though? Is it this one then? Okay, yeah, it is this one. Let's just submit it and see what happens. Okay, yeah, good. All right. I think this is a really important lesson for these like binary search edge cases where you really have to understand like why is this +1? Why is this like greater or equal? I might explain this in another video, but this is a really big gotcha. I think the most important thing to realize is that which half, like left or right half, which one are you trying to keep, right? Which one of them has the answer that you're looking for? So that's why I got confused in here. So I think this, I mean, it is correct for sure, but it depends on these symbols. Sometimes it's this, sometimes it's not that, blah, 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 but it really depends on which half of the divide and conquer that you're trying to keep and move on to the next file. I think that's the important thing to understand. Okay, so that's good. So this is the optimal solution, and the time complexity of this is like n log n, I believe. But I think it can be like n log n squared, right? So the sorting is in itself n log n. Oh, wait, no, it's not that because we're just doing iteration. Yeah, so it is n log n. Okay, so the sorting is n log n for sure. This is on, this is n log n, and this is also n log n because this one itself is a log n, right? Because we are doing binary search, so that's log n, and then we're doing n loop, so that equals to n log n. And then the space complexity is obviously O of n because we're having multiple arrays, right? Like has the 2 items. It's obviously that. Okay, that's good. All right, so we have 8 minutes left, and then let's just try to do this problem. Given the root of node binary search tree and 2 integers low and high, return the sum of the values of all the nodes with the value in the inclusive range of low and high. Okay, so it's a binary search tree. Okay, got it. Range sum BST. I'm pretty sure I solved this problem before, but still, it's not an easy problem at all. All right, so the most important thing that we have to do is that I guess whenever you're trying to go left and right, you have to decide. And then obviously there are some cases where you don't want to go left because it's already lower than the low, right? And then you obviously don't want to get to the right because it's already higher than the high. So I think that's the easiest bit to understand. So for example, like I think what I can do is the tree can be none. I guess it is node val. Okay, number of nodes is 1 to that. Okay. Should I? I guess that is the case. Okay, so if root dot val is greater than or equal to low, high, okay, what am I trying to do? I'm trying to do, if that is the case, then I'm returning the value. But that's not really true because I have to do recursion. So it's like plus. I have to analyze the left and right node as well. Okay. I see. Yeah. I'm pretty sure. Okay. So if it's within the range, I have to decide if I should go left or right. But I think this is a bad idea. So let's just try. The left is. Okay, so for this example, so I'm doing 8, 7, and 15. Oh, wait, I have 5 minutes? Holy shit, okay. I'm not sure if I can finish this in 5 minutes, but if I can concentrate, maybe I will. So if root dot left and root dot left dot val, so low. Okay, so this value doesn't really matter then because, oh yeah, I think I know what to do. If root dot val is greater or equal than our low, and there's a left node, then return range sum BST root dot left low high plus but now it has to be on the same page. Okay, there's just too much time pressure and I don't think I can concentrate really well. All right, let's see. I'll just ignore the time, and then I think I'm most likely gonna fail this challenge. I think I spent too much time optimizing the previous problem. Okay, so if the current one is 15 and the right one, yeah, I think I'm just gonna pause this for a second and then just focus on this really calmly because let's just say I failed for sure, like in here. I don't think I can focus and then solve this problem. No, sorry, and I have to focus in order to solve this problem. Yeah, I mean the easiest part would be just the easiest approach, the brute force approach, is obviously gonna be just iterate through all the nodes and then add the numbers as you see fit, right? So that's gonna be the easiest approach, but you have to optimize that. There are some cases where you don't want to go deep into the tree. So for example, like if you don't want to go like this node at all because you already know that this value is lower than your lowest, right? This one. So you don't want to go here, but you do want to go here. There might be values where it is, a 7. So that's why you want to go to the right. So that something like that you have to do. So let's just try to emulate that, right? So the root dot value is yeah, see, that's the thing. Because like in here, the root dot value is less than my lowest, but the right can be higher because of the parent node. I guess the parent node doesn't matter because we're checking on the other recursion, right? So it's tricky. Let's try to do this the brute force way, and then let's try to optimize it. I think that's the best. Oh yeah, it's a really good start too. If root dot val is lower than I, so I think root end like that, return range sum BST root dot left plus range sum BST root dot right plus root dot val, right? So that is one case. But is it everything then? No, it's not everything for sure. Okay. I think I have to separate these ones. I think there's too much of one condition here. So I think that this should be like some sort of val, not val. Let's just say S. So if the current value is greater than the lowest, then obviously we want to go left to explore more. If it is right, okay, not return. I think it's like that. And then if root dot val is high, then do something like that as well. So right, and I can do like and root dot. I guess I can do like if not root return 0. So if it's null, basically return 0. And then if I think I should do this one first. S root dot val return s. Okay, this might be it. Let me just check. It's not. Oh yeah, you have to pass in the low highs in here because it's a recursive function, right? Oh, what's wrong now? Okay, root dot left. Oh, I think it's oh yeah, in here it's you have to call self dot because it's a class function. Oh, what's wrong now? Oh, height. I think I've misspelled it. Okay. All right, cool. So I think that's the case. All right, yeah, that's it. Oh, I think I didn't exceed the time too much, but I think it may be like 1 or 2 minutes. Yeah, maybe 1 or 2 minutes exceeded the time, but I got pretty close. I think the time pressure, I was just feeling really nervous about it. So yeah, the most important thing to realize is that so this is like the basic condition, right? So if the root is not defined, just return 0. That's pretty self-explanatory. But the key is that you have to sum everything on the left, everything on the right, and also itself, and then return it at the end, right? So that's like the key. And in order to go to the explore the left, your value, it should be at least greater than your lowest one, right? So that's how you explore the left. And then as well as on the right, your high should be at least, I mean, it should be less than your current value. So that's how you explore the right. So that's like the exploration, like minimization, right? So that's why you don't want to explore that is obviously not within the range. So that's the trick. So these are the trick. And then this one is like finally the condition, right? You want to you want to add the root value also if the conditions are met. So that's how it goes. And I think this problem, time complexity, is like O of n too, like number of nodes, because you can explore every node, right? And the space complexity is like, I think, O of log n, because it's like a recursion stack, right? So we can go on to, I guess, technically, binary search can be O of n, because, the binary search tree can be just, just left hanging, right? So it just goes to the right. So that's how the recursion stack can be, O of n too. But typically, if it's a balanced tree, then it's going to be like log of n, if it is balanced tree. So height balanced tree, right? So that's it. So that's the problem, right? So I don't believe this is an easy problem at all. Like it's definitely like not as easy as what we're doing on these ones, but this is definitely like medium-ish easy, but it's the harder end of easy for sure, like in LeetCode. That's how I feel about it. All right, so I think that's about it. I think I'm pretty sure we've done like, oh wait, is this the 10th problem? Oh shit, okay, I didn't even see there was a 10th problem. All right, okay, I believe I also failed the challenge for sure because I didn't see the 10th problem. But what is this problem saying? Given an array of nums, we define a running sum of the array is like, okay, that's pretty self-explanatory. We also say this as a cumulative sum, right? So yeah, that's pretty self-explanatory. Obviously, the brute force approach would be just sum everything that is to the left, right? You just keep summing that was going to be O of n squared, but that's a really bad approach. And the good approach would be just keep like a s variable and then just adding on to it, right? So let's just do like run sum. And for n in nums, so the running sum is s is equal to an n, right? And then run sum would be just append s basically. So that's how you do it. I think that should work. Let me see. Oh wait, what? What is it saying? Oh, wait, what? I can't do this. What is it saying? Int is not iterable? Turn the handle left saying the object is not iterable. What? Is there like a name conflict or something? Nums, no. What is this? One, two, three, four. Oh, yeah, it's wait. Yeah. It's not S, it's run sum. Yeah, okay. Oh, it should, okay. All right, let's just do that again. Okay, yeah. I was just returning the wrong variable. I was so confused. The type didn't match. All right, cool. So basically, like you just keep track of one variable and then you just keep on adding to it and then append that variable instead of, calculating the sum from the beginning. So that's a really cool trick. Time complexity is going to be O of n, and then space complexity would be O of n also because we're returning n size array, right? So that's about it. Okay, so I think that's a 10 problem, and then I'm pretty sure I also failed this solution. So I think it's getting harder as I go move on. So I'm only at part 3 and I already failed. So I think I have to be really fast in order to complete it next time. So let's just go to our profile and see if there's actually 30 problems. Yeah, it is 30 problems. So that's good. I'm really shocked that I missed one problem at the end. I thought I was all done after the binary range sum tree, but range sum binary search tree. So yeah, hope you liked it, and then feel free to have any questions and comment down below. All right, see you on the next challenge. Bye bye.